The Great Pyramid of Giza contains approximately 2.3 million stone blocks. The lightest weigh around 2.5 tons, the heaviest weigh up to 80 tons, and every single one of them was placed with a precision that modern engineers still cannot fully explain. The Great Pyramid stood as the tallest structure on Earth for 3,800 years. From its completion around 2560 BC until the construction of Lincoln Cathedral in England in 1311 AD, nothing built by human hands rose higher. Not the Colosseum, not the Pantheon, not a single medieval castle or cathedral for nearly 4 millennia. And here is the fact that should stop you cold, that we have never successfully replicated it. Not with cranes, not with computers, not with every tool and resource the modern world can bring to bear. Every serious experimental archaeology attempt to reconstruct even a fraction of the Great Pyramid using methods available to ancient Egyptians has either failed, been abandoned, or quietly scaled back to something far smaller than the original. The question is not how they built it. The question is how we keep failing to understand something that was accomplished 4,500 years ago. Let's start with what we know. The Great Pyramid was built during the reign of Pharaoh Khufu, also known as Cheops, around 2560 BC. It was constructed over an estimated period of 20 years. That timeline has been confirmed by multiple independent sources, including the diary of a worker named Mirror, a papyrus document discovered in 2013 at the site of Wadi al-Jarf, the oldest known papyrus ever found. Mirror was an inspector. He kept daily logs. His diary records the transport of limestone blocks from the Tura quarry across the Nile to Giza. It describes teams, schedules, rations, and routes with the bureaucratic precision of a modern construction manager. The pyramid was not built by slaves. This is one of the most persistent myths in popular history and one of the most thoroughly debunked. The workers were Egyptian nationals, paid in bread, beer, and meat, housed in a workers' village excavated by archaeologist Mark Lehner beginning in the 1980s. The village had bakeries, breweries, a medical facility, and what appears to be a central administrative building. The workforce was organized, fed, and managed with extraordinary sophistication. How did they move the blocks? This is where experimental archaeology has made genuine progress and genuine mistakes. The leading theory, supported by wall paintings found at the tomb of Jehuti-Hotep and confirmed by a 2014 study from the University of Amsterdam, involves wet sand. A painting from around 1900 BC shows a large statue being dragged on a sledge across the desert. In front of the sledge, a worker is pouring liquid onto the sand. The Amsterdam study tested this. They found that wet sand reduces the friction coefficient of a sledge by up to 50%. With wet sand, a team of workers could drag a load that would be almost immovable on dry sand. Simple, elegant, almost certainly part of the answer. But here is what the wet sand theory doesn't explain. It doesn't explain how blocks weighing up to 80 tons were raised to a height of 146 meters. It doesn't explain how 2.3 million blocks were placed at an average rate of 1 block every 2 minutes for 20 years, assuming workers operated 12 hours a day, every day, with no rest days. 1 block every 2 minutes for 20 years. The ramp theory is the most commonly proposed solution to the lifting problem. Build a ramp. Drag the blocks up the ramp. As the pyramid rises, extend the ramp. The problem is the math. Architect and Egyptologist Dieter Arnold calculated that a straight external ramp long enough and shallow enough to drag blocks to the pyramid's apex would itself require more material to build than the pyramid itself. A ramp that could reach 146 meters at a workable angle would need to be approximately 1.6 kilometers long and contain an estimated volume of rubble greater than the pyramid's own mass. You cannot build a ramp that requires more material than the building it is serving. Various alternative ramp theories have been proposed: internal ramps, spiral ramps, zigzag ramps. In 2017, archaeologist Pierre Taulet and architect Yannis Gourdin announced the discovery of what appears to be an internal ramp system inside the pyramid itself, with notches carved into the stone that may have been used as anchor points for rope and lever systems. It is the most promising new evidence in decades. It explains the upper sections of the pyramid. It does not fully explain the lower sections, where the blocks are largest and heaviest. The complete picture remains unresolved. Every major modern attempt to replicate pyramid construction has run into the same wall. In 1978, a Japanese team from Waseda University attempted to build a small pyramid using ancient methods. The project was abandoned when the team found they could not move the blocks without modern equipment. They eventually used cranes and helicopters. The resulting structure was 11 meters tall. The Great Pyramid is 146 meters. In 1999, a Nova documentary project attempted to demonstrate pyramid building techniques using a team of workers, sledges, and ropes. They successfully moved a 2.5-ton block. They did not attempt an 80-ton block. They did not attempt to raise a block more than a few meters off the ground. The experiments confirmed isolated elements of the process. None came close to replicating the complete system. The coordination, the speed, the precision, and above all, the sheer scale. The precision is the part that modern engineers find most disturbing. The base of the Great Pyramid covers 53,000 square meters. Its four sides are oriented to the cardinal directions: north, south, east, west, with an average deviation of just 3/60ths of a degree from true north. 3/60ths of a degree. Modern GPS-assisted surveying routinely achieves similar precision. Ancient Egyptians achieved it using stellar observation, plumb bobs, and set squares. The base is level to within 2.1 centimeters across its entire 230-meter length, not 21 centimeters. 2.1 centimeters across 230 meters of desert, using no power tools, no laser levels, no concrete foundations. The Egyptians achieved a variance of less than the width of 2 fingers. The joints between the casing stones, the outer limestone blocks that originally covered the pyramid and gave it a smooth, gleaming face, are fitted so tightly that a sheet of paper cannot be slid between them. Yes, oh, what is the real reason the pyramid has never been replicated? It is not the blocks. It is not the ramps. It is not the tools. It is the organizational achievement. Archaeologist Mark Lehner, who has spent more than 40 years studying Giza, argues that the pyramid is less a feat of engineering than a feat of administration. To place one block every 2 minutes for 20 years requires not just a method for moving blocks. It requires a system, a city-sized logistics operation running continuously for 2 decades. That system had to feed, house, and medically treat a workforce estimated at between 20,000 and 30,000 people. It had to source stone from multiple quarries up to 800 kilometers away. It had to transport that stone by boat, sledge, and human labor across desert terrain. It had to maintain quality control on 2.3 million individual placements. And it had to do all of this without a single piece of modern communications technology. No radio, no telephone, no written real-time updates beyond papyrus and messenger. Every experimental replication attempt has focused on the mechanics, the sledges, the ramps, the wet sand. None has successfully replicated the management system that made the mechanics possible. That management system is what gets lost. The Egyptians had something modern experimental archaeologists consistently underestimate. They had done it before. Khufu's pyramid was not the first pyramid. It was not even the first large pyramid. Sneferu, Khufu's father, built at least 3 pyramids before Khufu began his. The Bent Pyramid, the Red Pyramid, each one a learning exercise, each one producing a workforce that knew the system, had refined the system, and passed the system down through institutional memory. It'd be why the time Khufu's project began, Egypt had been building pyramids for generations. The workforce was experienced. The logistics had been tested. The mistakes had already been made and corrected. Modern replication attempts start from zero every time. The Great Pyramid is not a mystery in the supernatural sense. No aliens, no lost technology, no secret knowledge that disappeared with ancient Egypt. It is something more impressive than any of those explanations. It is the result of a society that decided, over multiple generations, that one project was worth the total organizational commitment of an entire civilization. It is the result of accumulated institutional knowledge, refined through decades of trial and error, executed at a scale that has never since been attempted. That we have not replicated it, because we have never tried in the same way that we send a small team with cameras and a grant deadline. They send a civilization.